The objective of this practical is to determine the concentrations of caffeine in a black tea sample using HPLC. And it is to check whether the concentrations of caffeine is complying to the labeling shown on the packaging. For a hypothesis, it is assumed that the concentrations of caffeine in the black tea sample is 11 mg per 100 g of dried tea leaf as indicated on the labeling. Before we start, here is the introduction of what we are going to do in this practical. In fact, there are many bioactive compounds present in black tea such as catechins, gallic acid, and caffeine, which is a type of plant alkaloid. Black tea is fully fermented and has a high level of caffeine. Caffeine in tea has sparked great interest among the scientists and public, as some argue that it is beneficial to health and some stated otherwise. Therefore, an analytical method, which is HPLC, permits a fast and easy separation that can be used to quantify the amount of caffeine present. Some of the materials and apparatus that are required in these practicals include 1 tea bag in 100 ml of water, 1 liter of HPLC grade methanol to water solution as the mobile phase, 100 ppm caffeine stock solution, 650 ml volumetric flask, 3 10 ml beaker, 1000 microliter micropipette and tips, and lastly 200 microliter micropipette and tips.
First, we will be doing sample preparation. We will dilute 100 ppm of caffeine stock solution to 1, 3, 5, 7, and 9 ppm into 50 ml volumetric flask using mobile phase, which is 1:1 ratio methanol and water. Twenty microliter of different concentrations of standard and sample are injected into the vials. This will be used as standard solution. Next, we will be doing dilution for the sample by diluting 0.5 ml of black tea sample into 50 ml volumetric flask using mobile phase. The sample is then filtered using syringe and filter membrane. Now we will proceed to the equipment to conduct HPLC system. Then we put all the valves of the sample and standard into the injector system.
Dilution is required for concentrated sample to prevent sample overload. Besides, it can also reduce solvent strain, and strong solvent will disrupt the stationary phase. Samples are required to be filtered by string filter before injection to remove particles and reduce sample complexity. The particle might block the chromatographic column and thus leading to irregular flow rate.